3, Candy Crush. So for this problem, it is exactly like the Candy Crush game. First of all, yeah, so inside of this example, first of all, we're gonna check all the numbers, all the positive numbers, because all the candies are positive numbers. So let's just check that. So as we can see, the board ij always be positive numbers. Yeah. So for this problem, first of all, we're gonna check all the positive numbers, like we're gonna check all the rows. If there's at least like 3 numbers, it is the same in a row. Yeah, or 3 numbers, it is the same in a column. So basically, this is what we are looking for. Yeah, but we don't need to check like 4 numbers. We just need to check 3 numbers because we just need to loop through the board from each cell. We're gonna loop through all of them. Yeah. So for example, from here, we're gonna check all those 5. This 5, this 5, this 5. It is the same, right? Yeah. But let's just start from the beginning. Yeah. So let's start from here. So this is just from the beginning. So from the beginning, we're gonna check all the rows. So for this 2, this 2, this 2. Yeah. So for this row, it is the same. So we're gonna mark it as a -2. So this is gonna be a -2. And then we're gonna just scan column by column. If we find 3 numbers, it is 1, 1, 1. We're gonna set it a -1, -1, -1, and then we're gonna scan this one 1, 1, 1. We're gonna put it as -1, -1, and -1. Yeah. And similarly for this one, we're gonna set it as -2, -2, and -2. So this is gonna be the first step. Yeah. So the second step is gonna be the cross operation. So we're gonna cross from column to column. Yeah. So for the first column, it is exactly the same, right? Yeah. But for the second column, as we can see, all those numbers will be dropped down because those ones will be crossed. So this means we're gonna have 4 zeros because it is crossed. Yeah. And those numbers will go down, and it is the same for others. So this is gonna be the second image. So for the second one, we're going to continue to check. Oh, those ones we're going to mark, and we're going to mark this one, and we're going to mark those ones, and then we're going to cross it. So this is going to be the final state. So in the final state, we didn't find any positive numbers. So here we don't need to consider all those zeros. We only need to consider the positive numbers. Yeah. So in each of the row, we didn't find any 3 numbers that are going to be the same, or we didn't find any column numbers that are going to be the same. This means we finished our operation, and we're going to return the final state of the board. It's going to be this board. Yeah. But exactly how shall we do that? Yeah, we just make it simple, totally like a brute force. We only need to consider 3 numbers instead of 4 numbers or 5 numbers. It doesn't matter, because if we consider those 3 numbers, basically we checked all of them. Yeah. And even for the column, we only consider 3 numbers. Yeah. And after setting, the second step is that in this example, we're gonna check column by column, and we're gonna make the cross. Yeah. So for the cross, it's also easier. We just need to check the positive numbers. So for example, from the first one to the second one, for example, we're gonna do a cross. So for example, let's just cross the second column, this column. Yeah. And we just prepare a right place. So right row, it's gonna write from here, and then yeah, we just need to check all those positive numbers. So for example, for this column, there's gonna be a positive number here. So we're gonna set a 4 here. So 4 gonna be here. Yeah. And then we're gonna check this one. And the positive number is here, so this means 1 gonna be here. And for this one, the positive number gonna be here, so 411 gonna be here. Yeah. And for this one, the positive number is 311, so the 311 gonna be here. Yeah. So this is what we are doing. Yeah. So except that, we just need to check other positive numbers. So we still have this 5211. So we just put 5 and 211 here. Yeah, just connect it. Yeah. So after that, we're gonna find all those zeros. So from here, we're gonna set all those numbers to zeros. Yeah, we just need to use a variable to find the place, like a pointer to find the place. And here we're gonna set the pointer to here, and all those areas we're gonna set it to 0. Yeah, I think this is gonna be the whole operation about the class. So first we're gonna just do the marking. After marking, we're gonna do the crossing, and after crossing, we're gonna do the recursive function to check the next step. Yeah. Now let's just try to solve it. So we're gonna prepare row and column. It's gonna be length of the board and length of the board 0. Now we're gonna do the row by row. We're gonna do the row marking, and then we're gonna do the column marking. So for R in range with all the rows, and for C in range. So for the column, we're gonna set it from 0 to C minus 3. So from here, we're gonna use the C minus 2. Now we're gonna do a checking. So we're gonna use the absolute of the board with RC equal to absolute of the board with RC plus 1. And if it is equal to the absolute of the board with RC plus 2. Yeah. So if they are equal, so for example, for the first row, without some row, for example, those two are equal, and yeah, and not equal to 0. So it's the absolute value, because we're going to set it to a negative value. So this is why we're going to use the absolute value to check. So we're going to use the absolute value to check if they are equal and not equal to 0. If it is always equal to 0, we're going to never stop the recursive function, because later on we're going to write a recursive function. So here we're going to check if they are always equal and not equal to 0, so we're going to set it. So, but how can we set it? We're going to set the board RC going to equal to board RC plus 1, going to equal to board RC plus 2, going to equal to negative of absolute of the board RC. Yeah, we just need to set a negative value as I did before in this image. Yeah. And then we're going to set a flag. So here I'm going to call it to do. It means we're going to continue to do the next step. Yeah. So from the beginning, this to do is going to be a false. Yeah, because after I finish all those marking and crossing, I'm going to call the recursive function. I'm going to call the recursive self dot carry cross with the board. So if it is a to do, it means here I did some markings. Definitely I needed to do the crossing, and I needed to check the next step. So this means to do gonna be equal to true. Yeah. But for here, after this one, we're gonna do the operation. The to do gonna be the false. So this means we're gonna just return the board. Yeah. Now let me just copy and paste, finish the column marking. So for the column marking, for the row, it's gonna be R minus 2, and the column here gonna be C, and here I'm gonna be RC R plus 1 with C, and R plus 2 with C, because here gonna be on the column. Yeah. So let me just set it this one to R plus 1 with C, and here gonna be R plus 2 with C. Yeah. So similarly, I did the column marking. So after the marking, I can do the crossing. Do the crossing, I can do column by column. Yeah. So now I'm gonna do the crossing. So let's do it column by column. So yeah. For R in range, let's do it column by column. So for C in range C, we're gonna set a variable. Let me call it right row, gonna be R minus 1. Yeah, because we're gonna write from the bottom to the top. So this is exactly like the game. So for R in range with R minus 1, minus 1, and minus 1. This means we're gonna write the row from the bottom to the top. Yeah. So we're gonna have a check. So if the board of this cell is more than 0, basically we're gonna write it. Yeah. So the board with the right R, this pointer with C gonna be equal to baud RC. Yeah, you can just check exactly what I'm doing. So first of all, my pointer is here. So this my pointer is here, and then I'm gonna check the positive numbers. So my positive is here, I'm gonna write, and then from here I'm gonna check the numbers. Yeah. So this number is a positive number, so I'm gonna write this for here. Yeah. And I'm gonna continue to do on this kind of a column by column operation. Yeah. So if I write 1, so the right R, the positive operation gonna minus equal to 1. Yeah. So this one I finished all the positive numbers, but I didn't write the 0. I needed to rewrite the 0. So this means for R in range with the right R plus 1, I need to set the baud with RC equal to 0. And this is because, so yeah, still in this example, we write this one, write this one, write this one, and we're gonna continue. Yeah, and we're gonna, yeah, because we are checking the positive numbers, we just write this one and this one. We finished the right, and the right R gonna plus 1, right R gonna minus 1, so the right R gonna be at this position. Now it means from the top to the bottom, this position we're gonna write it as 0. Yeah, because right R is here. In Python, we need to use the right R plus 1. This means we're gonna write all those areas to be 0. So this is exactly what we are doing. Yeah, I think that's all for it. Let me just run it to check if it works. As you can see, it works. Now let me just submit it to check if it can pass. As you can see, it's pretty fast and it passes for all testing cases. Yeah. So let's just analyze a little bit about the time complexity. So normally, as you can see, this m and n gonna be really small. It is just 50 and 50. Yeah. So it is just 50 times 50, m times n. Maybe this is gonna be the time complexity, but actually it is not. Yeah, because this is just for one step. It determined how many calls we're gonna call this recursive function. So for each call of the recursive function, as you can see, our complexity is m times n. But how many calls? So just imagine for each of the calls, we may eliminate at least 3 cells. Yeah. So the time complexity gonna be square divided by 3. This means how many times. So for example, it's gonna be 25,000 times for each of the recursive function. But how many times? It is 2,500 divided 3. We just imagine for each of the time we're gonna eliminate at least 3. So here, basically, yeah, how to calculate? Let me put it. Yeah, so here, maybe this is gonna be. Yeah, yeah. Actually, it is this number. This number gonna be like 10 to the power of, I don't know, maybe 10 to the power of 6. Yeah, so this is why it's so fast. Yeah, let's just check the number. We're gonna check this number. 50 to the power of 4 divided by 3. We just want to check this number. Maybe it is 10 to the power of. Yeah, it is like 2 times 10 to the power of 3 and 10 to the power of 6. So this is why it's so fast. Yeah, because basically the time complexity is gonna be 10 to the power of 6. Yeah, I think that's all about it. Thank you for watching. See you next time.